Okay, hello students. This is the lesson number 19 and the learning target here explore the end behavior of rational function and also how can you write rational function into the form of qx plus quotient plus remainder. I'll go straight away to problem number one, practice problem. Here it is, first question. So the function is given something like this, can be written in the form this. So what do you think now? This can be written in the form they already gave us. So you don't have to break your head to do it. Of course, you can easily do this. There's x minus 3. Using synthetic, you can put a plus 3 here, opposite. And the other one is the numerator, you use 5 and then 2 and then drop the 5 down. This becomes 15 and multiply and put it here. And 15 plus 2 is 17. That's the remainder, see. So that means the dividend divisor is quotient plus remainder over the divisor. So this means whatever this part is, quotient is this 5, just a constant by itself, plus the remainder is 17 and x minus 3. So, so what is the AND behavior? So what this basically means, the quotient is 5. It means uh, so remember, there are two ways. One is the quotient is just by 5. It means there is a horizontal asymptote at 5 like this. So this is the horizontal asymptote. And you can easily detect it by this is 5 and there's a 1 here. So whenever the degree, see this is the equation and both has the degree 1, 1. So whenever the degree is, then you write the y is p over q. What are p and q? P is the coefficient of the leading term in the numerator, that is 5. So that's 5. And the Q is the leading coefficient of the term in the denominator. So that's the 1. So you get 1. So y is 5 is a horizontal line. Y equals 5. And the denominator is, you can see that x minus 3. This will be 0 if x becomes 3. So there is also a vertical asymptote. So this is at 5. And there's a vertical asymptote here, 1. So that this is the vertical asymptote. And the graph of this is, of the rational function is, so approaches, see this part, it has to approaches to. So you can check whether, what is the x-intercept here. To find where the graph crosses the x-intercept here, we'll have, we'll have to put the numerator equal to 0 and see when is this. The numerator is 5x plus 2 equals 0. If you subtract 2, and you get 5x equals minus 2, and you divide by 5, and you get minus 2/5. That means the graph has to go to the minus 2/5, maybe somewhere here. So that means the graph will look like this. This is how the graph will look like. And this side, the graph will go this side. What it means is when x approaches very large positive value, and you can see the y value, they go on. So the output is almost same as y equals 5. So the graph's value is almost becomes 5. So we say, okay, the y value, which is 5x plus 2, this value will approach to 5. That's all that means. You're supposed to write. And also on the left side, if you see, if I go this side too, even if x approaches to a very large negative value, the y value will approach to the same 5. This is the line that y, this is 5. So we say y equals 5. Now, all this, even though they did not ask us everything, but still it is good to know how we get the sketch of this also. So how did I know that the graph is this way only? Because there's an x-intercept minus 2/5. So that makes me to think that it has to be like this way. And this side is, it has to be this way because as you go closer to 3 here, as you go closer to 3 from right side, if this is 4 and if 3.5, 3.4, 3.2, and then the graph, the denominator becomes very large. So when the denominator is large, then the whole thing becomes infinity on this side. So question number 2, we can use synthetic division for this, do this one. And the top, the numerator is a quadratic. So the coefficients are 1, then plus 7. So it is 1, is plus 7, and then minus 70. And then because this is plus 2, you write minus 2, drop 1 down. Minus 2 times 1 is minus 2. This will be 5, and this will be minus 10, and you get minus 27. So, sorry, this is 12 here. So this is 12. This is 12. So it's become 22. So now, because the numerator was 2, now the new polynomial will be degree 1. That means it will be 1 times x raised to 1. And then this is plus 5. So plus 5. So this is the px, which is the quotient. So this is the px, and the remainder is this one, which is r. So when you want to write this, so this equation become now will be equal to x plus 5, that is the px, and the remainder is minus 22 upon x plus 2, and that's it. So this is how, if you want to know how the graph will look like, what that means is this, when the degree of the numerator is bigger than the 1, then you'll see there is no vertical asymptote, but it is like a horizontal, it's a slant asymptote. That's like x. So it is like y equals x plus 5. So that means starts at 5, 1, 2, 3, 4, 5, and then you have a line with a slope 1. So this will be, so something like this. So this is the slant asymptote. This will be the slant asymptote. And if you see in the denominator, x plus 2 is 0, and that is possible only when it is x equals minus 2. So minus 2 is undefined. So at minus 2, let's see, this is minus, there is a, so the vertical asymptote will be this one. That will be the vertical asymptote at minus 2. And the slant, there is no horizontal asymptote, so it is going to be a slant one. So what it basically means is the graph now, how the graph will look like is because, so this is the, so if you put x equals 0 here, what you get is minus 12 over 2, which is minus 6. So if the graph crosses at minus 6, so that means somewhere here, minus 6. So that means, so the graph will be it be the, as x becomes very large, the output is like plus infinity. So when they go this way, and then it crosses here and goes this way. See, this is how the shape will be, and the other one will be something like this. So little difficult, but as you go the next classes, you'll see that in this problem they didn't ask us the actual the thing, but we can easily find out the x-intercept and the y-intercept. So the one that I did was little wrong here because it has to go through minus 6. So it has to go through this minus 6, and then it will cross somewhere. So there will be two x-intercept here because the numerator is x squared plus 7x minus 12. So you have to either factorize or subtract. It is not possible, but you can use the quadratic formula and do, but that's not required here. So I hope that makes sense. Okay, so now they are given 1, 2, so 2, 3, 4, 5, and you want to know what is the graph approaches to, which this graph approaches to which one, either the first one, second one, third one, 4, or 5. All you need to know is whenever you have, let's say, p times x raised to m plus and something here, and the down one is q times x raised to n, all you have to think is option 1 if m is is less than n, so if the degree of the numerator is less than 1, then y equals to 0 is the horizontal asymptote. But if your m is equals n, then it becomes y equals p over q. It's just the whatever the number multiplies the x. But and that's the horizontal asymptote. But if m is greater than n, then y equals, you have to use the synthetic division or long division, figure out what is this answer, and that becomes the slant asymptote. But it can be also quadratic asymptote also. That is, if the when you divide, if the degree of the numerator is, or if the degree of the denominator is 2 less than this one, then it becomes quadratic. Okay, right now we are not worried about that. Let's go directly in this example. If you see here, there's no x in the numerator. It means the top one is x raised to 0 and the down one is 1. So it takes the down one is less. So straight away y equals 0. So this one, so why this will go directly here because the degree of the numerator. In this case, the degree is the same, so it is 2 over 1. See this? The both degrees are 1, 1. So the quotient will be 2 over 1. So you just have to say y equals 2. That's it. Here also, this problem also, there is a 2 and there is a 1 here. So this also goes to there. Now, the problem here is different. Here you need to really work out and figure out the answer because there you have to use this form. So it is like 2, 1, and 3. And the down is -1. So put a +1. So drop down the 2. And then 1 times 3 is 3. And you get 6. But the main numbers are this, right? So because the degree here was 2, now the degree will be 1. So it is like 2 times x raised to 1 and then plus 3. So this go directly here. But the other one, what about this one? This one, there's an x cube. That means 1. What is x cube means? It is 0. Sorry, it is 1x cube plus 0x squared plus 0x plus 0. So you have to put 1, 0, 0, 0 like this. And then down is -1. So I put +1. So drop down 1. 1 times 1 is 1. Combine, you get 1. And 1 times 1 is 1. Combine, you get 1. 1 times. And this is how you're supposed to do. And the remainder is 1. So the degree, it was 3, but now that it will be degree 1. So 1 less, so it becomes x squared and x and then number. So those numbers which are in, so this one will be 1, this one will be 1 plus 1, and this one will be 1, and you're done. And you get it here like this. See. So this is how you're supposed to figure out the quadratic. So this is the quadratic asymptote. And this one, the one that you did here is a linear or slant asymptote. So by just looking at it, because this is remainder is 0, so because it means, that means x plus 5 is a factor. So that's all it is. So when the dividend is divided by divisor, you get quotient and the remainder is 0. So that means it's like d is exactly like divisor times the quotient and you're done. So there's nothing much there. Another way to show is to whether the x plus 5 is a factor is you just do the opposite of that equals -5 and plug it in here x and check with the calculator and you will see -5 cube. So this is the remainder theorem. We can work this out and you'll still get 0. So the polynomial is given. The fifth one is this one. It means because it is degree 4, I have to have 4 factors here. So which other one is, and you can see you have to look up for I'll start with this 0. When x is 0, this is 0. The answer is 0, right? So that means it is x minus 0 is one factor. Then I'll take this one. F of 1 is 0. It means it is when x is 1, y is 0. That means this becomes minus 1. And then you also see here this part. When x is minus 1, it is 0. That means opposite of minus 1 is plus 1. And there is one more here. This means when x is minus 3, the y value is 0. So opposite of minus 3 plus 0, and you're done. That's all they were asking you to write in the factor form, knowing the values of x there, or the zeros. So they did give us the zeros, and we figured out. Question number 6 is the repetition. There's a cone with a volume. So there's a volume with a cone like this. So, and they gave you the height, this is h in terms of r. So they already gave you. This volume is 180 cubic inches. All you do, you put 2. So h of 2 equals 180 over 2 square and solve. Then you put h of 3 and check it out. And then you put 6 and that's it. And you can continue. So I want you to pause for a while and see what they gave us. Again, this is a cylindrical can like this. And surface area and the volume is 10 cubic inches. There needs to be a label around here. So you want to put it all around the label. So what do you think will happen when R gets closer and closer? What is the behavior of the function tells you? So this SR is given. Clearly, when you look at it, the R is down, and as R becomes as the radius R of the can gets closer and closer to 0, that means if it becomes very small, then and this whole answer will become the area. That means the area of the label gets larger and larger. That means it becomes very large. That's the behavior. And the second question is R gets larger. So if R becomes larger, so when R becomes very large, then you will see the area, this whole answer of that means the area of the label gets closer and closer to, so this will be almost approaches to 0. So that's the behavior of the area of the label depending on the radius. The closer, the smaller the radius, it will be like a skinny radius. See, this will be a skinny kind of a, that's what that means, like a skinny. And sometimes it can be wide radius. So this could be also the height. so so when R is large, so this is the radius is very large, and you will see that so you'll require more surface area around it. So, and the last question, problem number 8, is you have to match with description of its end behavior as x becomes larger. Now look at this. As x becomes large, the first one, you see this also becomes very large because there is no denominator. Now here, when x becomes very large, the whole thing, let me write here 9 minus x, so 9 over x. When this becomes a very large number, this whole thing, answer, everything will become almost like 0. You check this 99 over x, we can just cross this out and you get 99. That all that means is the whole answer, the whole y equals, let's call it a y, this y will be almost approaching to 99. If you see this one, 99 plus x, and divide by, you can always write it, split this as 99 over x plus or x over x. So it's like 199 over x plus 1. And you can see that this whole thing, when x becomes large, very large, this parenthesis becomes 0 and only you are left with 1. So the whole y function may be y equal. This y function will almost approaches to plus infinity. That's all. But by just looking at it also, uh, and you can easily also identify how is because of there's a 1 here, there's a 1 here, this is degree 1, this is degree 1. So naturally, last problem I think we have seen, that the horizontal asymptote, that means the whole thing approaches to 1 is because y is p over q, and p is the coefficient of the numerator leading term, and q is the coefficient of the. So you can just do that also, or you can see this way also. Clearly sees when x becomes very large, the everything is almost like 0 and you get 1. Then this part, 99x plus 9. By just looking at it again, the degree is 1, 1. So the coefficient is 99. There's a 1 here. So y equals 99. So the value of the whole expression gets closer and closer to 99. And the last one here, 99 plus 9 over x. But here, there's a 1 and there is a 9. So y approaches to 9 over 1, which is 9. So the whole expression will approach to 9. And I hope that takes care of all the problems. See you guys. And next time I'm going to do video for lesson number 20.